Hello everyone, welcome to Spark Study. In this video, we'll study about the response of second order system, which is nothing but the underdamped system. And when the system is subjected to unit step input, that's why the topic name will be a response of second order system subjected to unit step input. Okay. So why we are going for unit step input, as we have already discussed previously, that we have some test signal, that is the ramp signal, impulse signal, step signal, and also parabolic signal, out of which the impulse signal is not existing when time tends to more than 0, and similarly the ramp signal and the parabolic signal, we do not know what is the final value, so it actually increase with respect to increase in time. So that is why we do not know what is the final value of my input. That means we do not know the final value of my test signal. That is why if we are using those kind of signal to test some systems, even if we do not know what is the input will be, then how could we predict the system output? That is why we actually choose the unit step input, because we know that when step means it just start from 0 and reach with the maximum value and remain at the maximum value when time tends to infinite. Okay, so the maximum value, if it is 1, then it is called unit step input, right? And we have already studied about all the characteristics of systems, and we studied that when the system is second order, that means the maximum power of the auxiliary equation is 2, then it is called second order systems. Once the system is second order and the input is unit step, provided your zeta will be in between 0 and 1. Okay, in that case you will get under damped system. That means the system oscillate. First the system oscillate when some changes happen, then automatically the system try to make the system stable, okay, with some other final value. So this is the overall transfer function. We know that C of S by R of S is nothing but the Laplace transform of output to the Laplace transform of the input, that is the ratio, which is equal to the transfer function and is nothing but omega n square by s square plus 2 zeta omega n s plus omega n square. This is the actual view of a transfer function of second order system. Okay, you remember this thing, where the omega n indicate the natural frequency of oscillation. That means it is a frequency whose time period never changes, constant time period, that means constant frequency. But when the frequency changes, that is called damping frequency. We'll study about the damping frequency, that is called omega d, later session. Okay, so omega n is nothing but the natural frequency of oscillation, and here s is some constant and zeta is the damping ratio. Due to this zeta value, the damping occurs. Okay, so depending upon the zeta value, we have studied the system is underdamped, the system is overdamped, the system is critically damped, and all those things. Okay, so with all this input and with all this condition, that means second order system, zeta value in between 0 and 1, then input is step input. If you simulate this thing, or if you try to find out the output response and plot it in a graph, you will reach with this kind of graph. Okay, here you can see this line will be the final line. Okay, that means previously the system actually tried to vary in between this line, but when in this time t is equal to 0, suddenly one input happened, that is step input, then the system rise. Once the system rise from 0 to a maximum value, then it actually oscillate in between these two line and reach with constant value. So previously it was this value, and after giving input the response will be in this range. That means the previous stage and later stage actually changes. Fine, but what happened when time tends to infinite, the system will not again oscillate. That means the system will remain constant in between these two lines. So that depend upon your design. What is it may be a 5% gap, it may be a 10% gap. In this gap, you will decide by the design of the system. Okay, so obviously when the fast disturbance occur, the fast oscillation will be very high, that everyone know. So this peak is called overshoot. This point is called overshoot. Not only this point is called also overshoot. This point also overshoot. This point overshoot. This point also overshoot. So what about these points? These points called undershoot. This one undershoot. So this is overshoot. This is undershoot. This is overshoot. This is undershoot. But thing is, this is first overshoot. This is second overshoot. This is third overshoot. This is first undershoot. This is second undershoot. This is third undershoot. But when you use this formula to find out something, then you have, for first overshoot you have to put n is equal to 1. For second overshoot you have to put n is equal to 3, not 2, because 2 belongs to the undershoot. So if they ask what is the first undershoot, then you have to put n is equal to 2. Okay. Okay. Now we have some terms. It is called t. T means time, and here c of t, the time response. This is not the Laplace. This is a time domain specification, and we have seen the response start from 0 and reach the final value. So this is not final value. This is a peak value. This is the maximum disturbance can be happen. Okay, so the system has to be designed such that it can actually control the maximum disturbance. Let's say the system design you have designed can control the system up to 1. So when disturbance occur, the system will go beyond 1. Then if the system go beyond 1 or the response go beyond 1, but you design to control within 1, then this is not a good system. That means the system cannot be controlled. Okay, so you have to design your system such that it should be controlled. I mean the system design should be more than that of the MP. MP means maximum peak overshoot. Okay, so my desired value will be this line. This is the desired value. I mean this is the final value. You can see the line will be surrounded by this line. This is the final value. So what is my initial value? Obviously it is 0. Okay, from 0 to 1, I mean from 0 to maximum value, it was taking some time. This time is called rise time. TR, rise time. That means when your system actually travel from 0 to maximum value, I mean 0 to its original value or 0 to its steady state value, that time is called rise time. You can say, sir, this is the steady state value, this is also steady state value, this is also steady state value, and these are many steady state value. Actually, when the graph is traveling, it actually crosses the steady state value many more than one times. Then why this? So remember this thing. Rise time is the time taken by the system to reach its final value. It's a final value for the fast time. This is the fast time. Okay. Similarly, what is TD? TD is the delay time. Okay. Delay time means it is the time taken for the system to reach 50% of the final value. So this is final value, this is 50% of final value, right? So this is the time. This is called delay time. Similarly, peak time means to reach its first peak. If they ask, say, what is the second peak? Can you say what is the second peak? Whether this, I mean, you know, these are the peaks, and this is also peak, this is also peak. So this is first peak, obviously. Where is the second peak? Whether this or this. Second peak, obviously this. third peak is this, but this is second peak but fast undershoot. Clear? This is third peak but second overshoot. Okay. Similarly, you can find TP for all those peaks. So P can change 1, 2, 3, 4, 5, 6 up to N depending upon the oscillations. And this is TS, that is called settling time. That means it's the time taken for the system to settle down around this tolerance zone. So these are some terms you need to remember: TD, TR, TP, TS, MP. Okay, the very important things you have to remember. Okay, let's study one by one. So I have told you what is delay time. Delay time is the time required for the response to reach 50% of its final value for the first attempt. Okay, so this is the first attempt, this is second attempt, third attempt, fourth attempt, likewise. So in first attempt we are getting the required value. So for the first attempt, what we get in that time divided by 2, it means 50% of the first attempt. This is called delay time. So formula can be written as 1 plus 0.7 zeta by omega n, and the unity will be second. Remember, this is not the derived formula, this is an empirical formula. By many substitution method we have found this formula. Remember, no need to derive this formula. Derivation of this formula is not in your syllabus, you just remember this formula. And I gave it 5-star rating because we need to remember all these formulas. Okay. Next, let's go for study rise time, which is nothing but TR. As I told you, rise time is the time taken by the system to reach its first attempt. So the rise time is the time needed for the response to reach from 10% to 90% or 0% to 100% of the desired value of the output at very fast instant. So you might have confused what about 10%, 90%, then 0 to 100%. That actually depends. When you take 0 to 100%, that means it must be under damped system. That means response should be like this. For under damped system, the rise time will be time between 0 to 100%, completely cycle. And if the system is over damped system, then you have to take from 10% to 90%. Okay. Anyhow, your formula remains the TR is equal to pi minus theta by omega d. There are many derivations to reach with this formula. Okay. So pi minus theta by omega d, where theta is equal to cos inverse zeta. Obviously it is in second. Next, we will reach with peak time. I told you this is the peak time from 0 to maximum value first attempt. So we can write the peak time is the time required for the response to reach the first peak of the overshoot. Okay. So this is the first peak of the overshoot. So this is called MP, maximum peak overshoot, and first peak must be maximum, and the time between 0 and MP time is called as TP, that is called peak time, and the peak time will be defined as the n pi divided by omega d, where n can be either even number or odd number, because I told you this is 1, this is 3, this is 5. Okay. So the odd number constitute the overshoot, and 2, 4, 6 up to n minus 1. So this undershoot constitute the even number. Clear? Similarly, if they ask according to, remember to read the question carefully what they ask, then apply the formula or apply the value of n. Next, peak overshoot. What is peak overshoot? The maximum positive deviation. Okay, that is called the maximum positive deviation or the first peak of the output with respect to its desired steady state value is known as maximum or peak overshoot. This is important thing, very important thing. That means why it is important. I told you previously. Again, I am telling you. If someone asks to design, or you are a designing engineer, you need to design the system which can tolerate the maximum overshoot. Okay. If the system is not able to tolerate the maximum overshoot, then you cannot able to control. Okay, let's say you have a incandescent lamp which is rated to operate between 150 volt to 230 volt AC. Okay, this is the operating range. That means you are a designing engineer, you design the system to operate between 150 to 230 volt AC. But due to some disturbance, your voltage rise to 250 volt. But the operation value will be 150 to 230. But due to some disturbance, your input voltage increased to 250 volt. So what happened? The lamp will burn because it actually operated between 150 to 230 volt. But as a designing engineer, if you know your power system, when it gave some fault, it go up to maximum 250 volt. That means peak overshoot is 250 volt. With considering this peak overshoot to 250 volt, if you design your system to operate between 150 to 260 volt instead 230 volt, then if this disturbance occur, then also your incandescent lamp will not burn, it will operate. Okay, that is why peak overshoot is an important thing, and peak overshoot formula is the CTP minus C infinite divided by C infinite into 100. So which will actually gives the value e to the power minus zeta pi divided by under root 1 minus zeta square. Okay, when you try to find in percentage, you have to multiply with 100, and this odd number and even number constitute the overshoot and undershoot. This I have told you again and again. You remind this thing. Clear? So these are some value, some parameters to remember. And where one more thing is omega d. Omega d is omega n under root 1 minus zeta square. You need to remember that formula also. I have forget to give the formula. I repeat, omega d. Omega d is equal to omega n under root, omega n into under root 1 minus zeta square. Okay, so this is the things. One more thing is settling time, important, because I forget to tell this thing. This time from here to here, this is called settling time. Okay, so settling time depends upon how much tolerance you need, whether you need 2% band. This is the difference between these two is 2% or 5%. So when your system becomes band very less tolerate, then your time will be increases. Okay, so if it is 5%, if TS will be up to this, when it go for 2%, US will increases to more. So as your tolerance very less, then system is very accurate. When your tolerance is more, the system is less accurate. Okay, so what is the settling time? It's the time required for the response to reach and steady with the specified tolerance band. The band is usually 2% or 5%. We have taken we are taking in the study purpose, and this is the lab maintained value or the industry maintained value. So either a 2% or 5% is the good choice. For an underdamped system, the magnitude of the oscillation present in the output time response decay exponentially with a time constant 1 by zeta omega n. Okay, so with time constant, we need to find out the steady state time or settling time. Hence, the time setting or settling depends on the largest time. Okay, so TS settling time for 5% tolerance will be 3 times of the this time constant. So this will be 3 divided by zeta omega n is equal to 3 tau. Similarly, for 2%, it will be 4 by this value 4 tau. Okay. So these are some formula you need to remember. And if you have any doubt, you can ask me in comment section so that I can reply you. Thank you very much. Thank you for watching this video. Remember, if you like this video or content, don't forget to like, share and subscribe to the Spark Studies channel so that we can get with new update. Thank you very much.